X minus y. Got it. So x minus y belongs to Z. Okay. X minus y belongs. Second bit. Second bit. Let R belongs to Z. Let R belongs to Z. Let R belongs to Z. R belongs to Z. And A equal to Nx. A equal to Nx. Belongs to Nz. Belongs to Nz. Then A star R. A star R equal to Nx. Nx star R. That equal to N you take it outside. Hmm? This can be written as XR. 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 Which belongs to Nz. This belongs to Nz. Because XR or RX belongs to Nz. Nz. It is RX belongs to Nz. Nz. Okay, so therefore Nz is an ideal of the ring Z. Therefore Nz is an ideal of the ring Z. The ring Z. Ring Z. So note that any ideal Z must be any ideal any ideal any ideal of Z must be of the form must be of the form Nz. We of the form Nz. So N is lies between 0 to N. 0 less than or equal to N. N belongs to Z. Next page. So yeah, important for 5 months. One more example. This is also important for 5 months. Example. Page number 180. Page number 180. 180. The set Z of integers set Z of integers the set Z of integers is only a subring is only a find. This is also find solution. Find the set of only a subring. Only a subring, but not an ideal of ring. But not an ideal of ring. Ideal of ring. This is nothing but set of rational numbers. Triplet of rational numbers. Rational rational numbers. Rational numbers. Solution. Solution. We have A, comma B belongs to Z. It implies A minus B belongs to Z. And AB means product is also belongs to Z. This shows that Z is a subring of ring Q. This shows that. Estimate show that. This shows that shows that this shows that Z is a subring of a ring, subring of a ring Q. The product of rational numbers, the product of rational numbers rational numbers the product of rational numbers and an integer in an integer is not necessarily an integer, is not necessarily an integer. An integer. For example, 2 belongs to Z and 1 by 3 belongs to Q. Belongs to Q. But 2 into 1 by 3 that equal to 2 by 3 does not belongs to Z because it is a rational number, right? So Z is not an ideal of ring Q. Therefore, Z is not an ideal, not an ideal ring of Q. Ring of Q. Similarly, Q is only subring. Similarly, Q is only subring is subring of R. No? Subring of R. But an ideal ring of it, not an ideal ring of it, an ideal ring of R plus star triplet. So hence the solution. Next. Next example, important for theory 10 marks question. Example 3. What is that? Prove that S is not a ideal ring of M2. Prove that M2Z, let M2Z be the ring of all, be the ring of all 2 cross 2 matrices. Cross 2 matrices over Z under addition and multiplication. Under addition and multiplication. Under addition multiplication. The ring of all 2 cross 2 matrices. Solution. Let S equal to A0 0B such that A comma B belongs to Z. Means set of integers is a subring of M to Z. Subring of M to Z. Subring of M to Z. Then from A0 0B comma C0 0D belongs to S, where A, B, C, D belongs to S, belongs to Z, not S. And set of integers. We have A0 0B minus C0 0D, that equal to A minus C 0 comma 0 0 is 0 comma 0 0. This is B. This is B minus D. which belongs to S. Belongs to S. Here A minus C, comma B minus D belongs to Z. Belongs to Z. And A 0, 0 D. C 0, 0 D. Product this is. So matrices multiplication R1 C1. You know that. So R1 C1 means AC plus 0 means AC. R1 C2. R1 C2. 0 0. This is 0. Next. R2 C2. This is 0. Next. R2 C2. That means BD. BD. It belongs to S. It belongs to S. Where AC comma BD belongs to Z. Next page. Therefore, S is a subring of. Therefore, S is a subring of M to Z. M to Z. M to Z. Subring of M to Z. Further for any. Further. For any. Further for any. PQRS. PQRS belongs to M to Z. Where PQ where BQ RS belongs to Z means set of integers meaning. And A0 0B belongs to S. Belongs to S. Where A comma B belongs to Z. So we have PQ RS into A0 0B. A0 0B. That equal to R1 C1 R1 C2 R1 C1 multiplication PA R1 C2 R1 C1 C1 is over PA. Next R1 C2 0 QB. It's QB. QB. RA SB. SB. But does not belongs to yes. If QB is not equal to 0, if QB is not equal to 0, UV is not equal to 0. UV is not equal to 0. RA is not equal to 0. Not equal to 0. Therefore, S is not a ideal of F2. Therefore, S is not a ideal of M2Z. Right? Hence the solution. Next. One more theorem. This is of 10 marks. 10 marks important. Page number 181. Theorem. Statement. Prove that. Duty means prove that I and J be ideals. Prove that. Prove that the intersection of any two ideas, intersection of two ideals of a ring R, a ring R is again an ideal of R, is again an ideal of R. N ideal of R. Proof. Let I and J be ideals of ring R. Let I and J be ideals of ring R. Ideals of ring R. Ring R. Then 0 belongs to I and 0 belongs to J, and therefore 0 belongs to I intersection J. Intersection is a non-empty subset of 1. So that I intersection J is a non-empty subset of R. A non-empty subset of R. Subset of R. Next, we had page number 182. Let A comma B, A comma B belongs to I intersection J. Then A comma B belongs to I. Belongs to I. And A comma B belongs to J. And A comma B belongs to J. Let A comma B belongs to I. I is an ideal. A comma B belongs to I. mm, mm, mm. I is an idea. Idea. A minus B belongs to A minus B belongs to I. Similarly, A comma B belongs to J, and J is an ideal. And J is an ideal. J is an ideal. A minus B belongs to J. So A minus B belongs to I. Here, what we observe, A minus B belongs to I, and A minus B belongs to J. That implies A minus B belongs to I intersection J, intersection J, I intersection J. So R belongs to capital R, A belongs to I, A belongs to I. I is an ideal of R. I is an ideal of I is an ideal. I is an ideal of R. Ideal of R. That implies RA belongs to I, belongs to I. And AR belongs to I. AR belongs to I. Belongs to I. So R belongs to capital R. Similarly, A belongs to J. J is an ideal of R. J is an ideal of R. Ideal of R. J is an ideal of R. That implies RA belongs to J, and AR belongs to J. AR belongs to J. So now RA belongs to I. A belongs to I. And RA belongs to J. And RA belongs to J. That implies RA belongs to I intersection J. I intersection J. So similarly we can write similarly AR belongs to I, and AR belongs to J. That implies AR belongs to I intersection J. I intersection J. Therefore, I intersection J I intersection C intersection D is an ideal of R. Is an ideal of ideal of R. Ideal of R. So still here is hence proved. This completes the proof. Right. Next. Next, this is also an important theory for 10 marks. Here. If R is commutative ring, is commutative ring. Commutative ring. R is commutative ring. And A belongs to R. A belongs to R. Then I equal to I equal. Means prove that. Question formation is prove that R is a commutative ring and I equal to R A such that R belongs to R. R belongs to R. R belongs. Is an ideal of R. Is an ideal of R. An ideal of R. Proof. For 0 belongs to R. 0 belongs to R. 0 A that equal to 0 belongs to I. I means ideal. Therefore, I is not a null set or empty set. And I is subset or equal to subset to R. Subset to R. So let X comma Y belongs to let X comma Y belongs to I. Ideal. Then X equal to R1A. Then X equal to R1A. Y equal to R2A. For all R1 comma R2 belongs to capital R. Proof. Proof. Sorry, this is R1 R2 belongs to. So X minus Y. X minus Y. X1 means what? R1 A. Y means what? R2 A. In these two terms, take A is common. That is R1 minus R2. R1 minus R2A. R2A. That can be replaced. R A belongs to I. Since R1 minus R2, R1 minus R2 belongs to R. Belongs to R. For X belongs to I. X belongs to I. And the small r belongs to capital R. Small r belongs to capital R. X star small r that equal to R1A R1A into R that equal to R1 into AR that equal to R1 into RA. R is a commutative here. Yes, R is a commutative property satisfied. Commutative, commutative. Next page. That equal to R1 R1 into A belongs to I, belongs to I. Since R1 R belongs to R, R1 into R belongs to capital R. So since R is computed to Rx equal to XR, since R is commutative, commutative, R is commutative, XR equal to Rx belongs to I. XR and Rx, X belongs to I. That means X belongs to I. Small r belongs to capital R. So XR equal to Rx equal to X belongs to I. Same. So thus I is an ideal of R. Thus I is an ideal of R. Similarly, R is a commutative ring. Similarly, R is a commutative ring. Commutative ring. R is a commutative ring. A belongs to capital R. And the set, and the set, and the set, and the set. Here R such that R belongs to capital R is an ideal of R. Ideal of R. So hence proof. This completes the proof of the theorem. 10 marks question, most important. Next, two theorems are there, three theorems. 9 point definition. 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 Let R be a non-trivial commutative ring. Let R be a non-trivial commutative ring. complete protein. Complete protein. Complete protein. Complete protein. Complete protein. With identity. Complete protein. With identity. Identity. An ideal of I of R is called an ideal of an ideal of I of R is called principal ideal of R. Principal ideal of R. Ideal of R. Principal ideal of R. Principal ideal. I equal to AR that equal to AR such that R belongs to capital R for some element A in R is denoted by it is denoted by is denoted by is denoted by it is denoted by within the square bracket A. That is a principal idea of that meaning. So using this definition, theorem 9.2.14. 9.2.14. Prove that ring Z is integers is the principal ideal of ring. For 10 minutes. Next, 9.2.15. Prove that every field is a principal ideal ring. Principal ideal ring. So this is 1 month. This is for 5 months. A short answer. This is a long answer. 10 months. Next. Maximum ideal quotient rings. Page number 188. Page number 188. Page number 188. 9.3.1. 9.3.1. This is long answer time. That means 20 marks question. 20 marks. 20 marks. Do it yourself. Next, 9.4.1. The 10 marks questions. 192. 192. 9.4.1, comma, 9.4.2, comma, 9.4.3. In these three, one theorem is for 10 marks. For 10 marks input. Okay.
Okay, sir.
Hello. This is 9.4.1. Nine point 4.1, 4.2, 4. In these three, 10 marks question possible. Okay. Understood? So all theorems are possible.
Yes, sir.
Yes, sir.
Okay, time is up. Only 1 minute is there. Any doubt? Because all theorems are unable to teach within 1 hour. Right? Few theorems important what I said. That you see. Okay, thank you. I'm leaving.
Thank